Right, just a quick review on what we did last day. Right, so last day we stopped at the exponential function we did in the seed, right? We learned about this function here, y is equals to 8 to the power of x. Any function of that form will look like that. Okay? Right, so today now we're gonna do a function that is the inverse of y is equal to 8 to the x. Right? And you all might remember from math. So you all will do function and after take that one, right? Yes. Right? Inverse of a function is the reflection. So if I reflect y equals to 8 to the x in the line, y is equal to x, I will get y is equal to log 8 to the x. Right? That's a log function. So how are they related? Log 8 to the x is the inverse of 8 to the x. All right? They are the inverse of each other, and that's what the graph looks like. Right? So today we're going to focus on logs and something called log, right? Firstly, how to go from exponent to log. Right? So we need to be able to go from one to the next. So if I gave you a to the base equal to c, to convert to the log form, what do we do again? To convert from this to log, what do you do? Right? Bring down the a becomes the base, bring across the c becomes the value you find the log of, and b is the answer. All right, let's do something that we know. Let's say 5 squared is equal to 25. If we convert this to logs, this will be equal to log of the base 5 to 25 is 2. All right. Check this one out. What will this be? Log to the base 5 of 1 is 0. Just try one more because Nikolai get it wrong. 5 to the power of 1 is 5. What is that? Log 5 is what? Right? Log 5 is 1. Okay, so that brings us to some rules. Let's do the rules that we know already. Look at the last one. Log to the base a of a is always what? 1. Log to the base a of 1 is always what? 0. Look at there. Log to the base a of 1 is always 0. All right. Next rule. You gotta remember this rule here. M to the power of n. What is do with the m? Bring the n in front. So that's log to the base a of m. All right. Number 4. Log to the base a of m plus log to the base a of n. Same base addition sign. So what you do? Multiply. All right. Right? What's this here? Log to the base subtract log to the base a of m divided by m. Are you okay with that? Yeah. What about this rule here? What is log to the base a of m divided by log to the base a of n? What will that be? Same base and divided. What to do? No, that's not a rule, right? This is not a rule. There is no rule for this. No? Minus is when it's like this. So this is not a rule. So do apply the rule here, right? I'll just write it. Let's do what does it. Right? Only if you have multiplication, it can be broken up to give you addition. Right? Not log of something divided by log of something. Right? That's not the rule. Number 6. There's a new rule. It's called change of base. So sometimes we will not have the same base and we are limited to change it. Right? Sometimes we have to be able to change it. So let's do the change of base. Let's go from base A to base C. right? So if I give you a log to the base a of m, what will that be? Right? Watch this here. If you have to change the base from base a to base c, it becomes log to the base c, log to the base c, right? I'm changing to the base c, right? So I'm taking up a and applying c. What goes here is the whole number. What goes here is the whole base. So you want to convert log a to the base c. You put the c and the c here, whole number here, whole base here. For example, let's try to convert this to the base 10. Right? What will log of 100 to the base 5 be? You want to convert to the base 10, right? Log 10, log to the base 10. The whole number goes here, and the whole base goes here. And you work it out. Check it in the calculator and see. Check it in the calculator, see what you get. Check it in the calculator, see what you get. The last thing that we're going to learn is that everything that we do here, we could do it for something called ln. Right? And the reason we can do it for something called ln is that log to the base e is simplified as natural logarithmic or ln. Right? So every time it's ln, ln is the same as log to the base e. All right? If I give you a question with ln, you could use all these rules with ln. All right? All these rules here with ln. So every single one of these rules could work with ln. All right? So let's start here. What do you think is ln e? Aryan said that ln is log to the base e. So log to the base e of e is 1. What about ln e to the 5? What will that be? Right. This 5, I can use the power rule. This 5 come in front and it will be 5 ln e. And we know that ln e is what? 1. So the answer is 5. That's okay? What about let's try and simplify this as far as we could. Ln x squared minus ln x. Copy it down. Let's try that. Right, so what does it simplify to? Right, you have a few options. You can take it 2 and put it in front and simplify it. Or ln subtract. You can use this, right? You can use here. Same base, subtract sign. All right. So we could use ln x squared over x. This will cancel, right? So you'll get ln x. What about if we have to solve something like this? 5 to the x is equal to 4. What do you do here? The problem here is that we can't convert 4 to the base 5. Okay, nor 5 to the base 4. So what you have to do here is you're going to take logs on both sides. So you're going to get log 5 to the power of x is equal to log 4. Right? You can take the x and bring the x down here. Right? And then make x the subject. So x is equal to log 4 over log 5. Right, but here's why I show you that, Nikolai. Suppose I asked it this, Nikolai. E to the 2x is equal to 4. How do we solve for x? Right. So instead of taking logs on both sides, we take ln, right? So we'll get ln e to the 2x is equal to ln 4. I could take this 2x and bring it in front here. But what is ln e? Ln e is 1, right? And ln 4 is something in the calculator, right? So x is equal to ln 4 over 2. Right, so if you see a ln question, same rules that you would apply for log, you apply it for ln. Okay? So let's make a note of that, please. All right, nice. So let us start taking a look at some questions, right? So the first one that we're going to do is 2008. I'll guide you along. In fact, you will tell me how we could solve this, right? Log to the base 5 of x plus 3 plus log to the base 5 of x minus 1 is 1. How are we going about this here? What's the first rule we can apply here, Shavish? Same base. We could, yes? So we have the same base addition sign. So it will be log to the base 5 of x plus 3 by x minus 1 is 1. Right? Whenever we change, what to do? Kill it. Expand. All right, yeah, and then what? Anybody remember how to do this? So whenever we share, you have two options. You can take this and convert to exponential form, right? And then solve it. Or instead of writing 1, you could write log 5. Because we know 1 is log 5. And since we have log on this side and log on this side, we could cancel logs. And then you will expand this out. Then expand this out. X squared plus 3x minus x minus 3 is equal to 5. Right? So look what I did. I made sure that the same log and cancel off. Right? And then we get a nice little quadratic. That's x squared plus 2x minus 8 is 0. And you solve it. Right? Most likely you could probably factorize. X is what? Positive 4. X is minus. So we got 2 and minus 4, but we have a slight problem. What's the slight problem with the two answers? All right. If you remember the log graph, right? The log graph doesn't exist on the negative side. Right? So you can't find log of a negative number. So if you put 2 in here, it works out nicely, right? That's okay? But if you put minus 4 in here, you're getting negative values. So it will not work here. So therefore, the only solution is x is 2. But what will happen if it's not the same base, Shavish? If it's not the same base. So if you do get the same base, all you have to do is change the base and apply the rule. We have to be able to use the log rules and simplify this out. It said do not use calculators. Try and use the log rules and simplify this out. Don't worry too much about what's happening here. What happens here will happen down here. So do write out 5 and 6 and 7 and do write out. All right? How are we going to work out something like this? Try in your book and see what you get. So what you recognize? Everything can cancel. Not everything. Right? So you have 1 on 2. Addition means multiplied by 2 on 3. Addition means multiplied by 3 on 4. Multiply by, in fact, I'm doing one more because I want you all to see it. In fact, let me do it. I want you all to see it. But you don't have to do this in the middle, right? You don't have to do the whole thing. What you will recognize here is what? This will cancel here. This will cancel here. You all recognize that? So all will cancel except for the smallest and the largest. So that will be, no, you don't have to write all this. You just write in these 3 and you will see the pattern. Write these 2 and you'll see the pattern. So you're going to be left with log 1 over 10. How much is that? So you're going to get log to the base 10 of what? 1 on 10, there are 2 options. You could write it like this. Or you could say 10 to the minus 1. Log to the base 10 of 1 is 0. Log 10 is. So the answer is minus 1. All right, let's go again. 2009. Right? This is log to the base 4 of x is equal to 1 plus log to the base 2 of 2x. Question said that x must be more than 0, right? Try that, please. So there's a problem here, Sarah. Different base, right? It's up to you. You can convert the 4 to 2 or 2 to 4. Normally, it's convert the bigger to the smaller. All right? So convert base 4 to the base 2. What will that be? Log 2 here, log 2 here. What do I write here? What do I write here? 4. Simplify it out. 1 plus log 2 2x. What is log 2 to the power of what is log 4 2? 2, right? Because 4 is what? 4 is 2 squared, and I can take the 2 and bring it 2 here. Right? So we're getting log to the base 2 of x all over 2 is equal to 1 plus log 2 to the 2x. So I will get rid of fraction. Multiply everything by 2. So multiply everything by 2. We'll get log to the 2x is equal to 2 plus 2 log to the base 2x. What's the next step? Bring the logs together, right? Any question you're doing, you're bringing like terms together. So you're bringing your logs together here. Log to the base 2 of x. Bring across the plus, it becomes minus. Log 2 to the, sorry, I want to leave it 2 here and I'll show you something after, right? Is equal to 2. So now we have log to the base 2 of x minus this 2 becomes power, but a common mistake is that when you put in power, you just put 2x squared. But remember, it's the power of the 2 and the x. Okay? Is equal to 2, and you can write log 2 here. Right? This will allow you to have everything in terms of log. So this will be log to the base 2, subtract, same base. So we're going to divide. That's 4x squared. Bring this 2 here, and you will get log to the base 2 of 2 squared. This will cancel with this, and you'll get x over 4x squared is equal to 4. Right? If you want, you can just cancel it off here. But I don't want to cancel off in case we lose a solution. So I'm multiplying it out. Cross multiplying. I'll get 16x squared is x. I'll get 16x squared minus x is 0. When you solve this, you'll get x is 0 and x is 1. Right? But the question said x must be more than 0. So the only solution is x is more than 16. Right? So watch this here. All I did is I bring the logs together, and I took the power and put it here. And I expand this out. Right? When I expand it out, minus, same base, so I divide. Okay? And then I carry the 2 here and I drop off the logs. And I solve. Okay? The reason I didn't cancel the x here is I didn't want to lose the solution. Right? And sometimes when you simplify and cancel it off, here's the solution. Let's start here. Right, so part 1 is supposed to be easy. So the first part is simple, right? Because the 1/3 by the 3/5 by the 5/7 by the 7/9 by the 9/10, right? And we learned before only the smallest and the largest will remain. That's log to the base 10 of 1/10, which is minus 1. All right. So what does this mean? What's the first value in this term here? When r is what? 1 over r plus 1, which is 1 over 2. What's the next term? Log to the base 10 of what? 2 over 3. And then we go in what? All the way until we reach 99 over 100. So what will remain? 1 and 100. This will cancel, right? You'll end up with 1 and 100, which is minus 2. We just doing it e to the x and the log. Let y equal to e to the power of x. So we are going to get y plus 1 on y minus 2 is 0. Right? We do like this fraction. So we can multiply everything by y. And you'll get y squared plus 1 minus 2y is 0. This is a quadratic. And you get y to be what? 1. But you can't just leave the answer as y is 1. What you have to do? Right. We'll write it back. Make a substitution and you'll get y is 1, right? Or e to the x is 1. How do you solve questions like this now? E to the x is 1. Take ln on both sides. So you'll get ln e to the x is equal to ln 1. X is equal to ln 1 or 0. Answer is 0. Right? You'll get x by ln e is ln 1. Ln e is 1 and ln 1 is 0. Next one, we have log 2 x plus 1 minus log 2 3x plus 1 is 2. This one easy because they're both in the same base, right? Right? Same base, what you do? Right. Same base, subtract, we divide. Right? I just going to try the next technique here, right? I'm going to convert to exponential form. Right? So I'm going to go from logs to exponential. I'm just doing the reverse. Just to give you a different technique, right? So remember, this 2 will come up, this 2 comes back across, and the answer is x plus 1 over 3x plus 1. So you're going to get 4 and 1 is equal to x plus 1 over 3x plus 1. Cross multiply, and you'll get 12x plus 4 is x plus 1. You'll get 11x is minus 3, x is negative 3 on 11. All right, last part. Right, look at the first one. It's a little bit challenging. They want you to prove that this is equal to this. So you have to start here, the proof, right? You have to show that this is equal to this with the help of this. It's one hard, right? Because you have to understand what it's saying, right? You have to take this left hand side and you have to show that side in. So when you reach here, what you can do is what? When you reach here, what you can do? Take a trim place here. So you'll get log to the a plus b all over 2 cubed. That's okay? That's what you get, right? So by looking at this and looking at this, what you probably have to do here, you have to cube the a plus b all over 2 cubed, which is 8. So there must be a way for us to expand this out, right? So how we expanding a plus b cubed? How we expanding a plus b cubed? By a plus b. So you have to expand this out. So focus on 2 first. When you expand out these 2, you'll get a squared plus 2ab plus b squared, right? This by this, and so on, right? Multiplied by ab. So you have to multiply this by ab. So a by this is a cubed plus 2a squared b plus 8b squared. So I multiply a by this and this and this. Then I'm going to multiply b by this and this and this. So I'll get a squared b plus 2ab squared plus b cubed. right? See if there are any like terms that I could bring together, right? I just bring in the cubes together, and I have 2a squared b plus 1a squared b. That's 3a squared b, and I have ab squared plus 2ab squared. So that'll be 3ab squared. All right? Anybody recognize what is a cubed plus b cubed plus 3a squared b? This here is equal to 5ab squared. So I can take off this and just add it to 3ab squared, and I'll get 8ab squared. So I can come back here now, right? And instead of writing a plus b all cubed, I could write log of this here. This here we simplify it to 8ab squared, and I'm dividing it by 8. The 8 will cancel, and you'll get log ab squared, which we could break up easily. Log a plus log b squared. I'm bringing 2 in front. Log to the base a plus 2 log to the base b.